Securing the power and utility infrastructure in the United States has been thrust into the national spotlight and onto the public agenda over growing concerns with national security. Power and utility owners now more than ever must find innovative ways to leverage state-of-the-art technology and tip-of-the-spear subject matter experts to secure their assets in a cost-effective way. A foundational component to site security is a robust 3D as-built. Using terrestrial laser scanning, photo data acquired from UAVs, or a hybrid approach of both techniques, a comprehensive point cloud can be generated that serves as a highly precise spatial model of utility assets, site topology, and existing conditions. Acquiring site data with UAVs minimizes the need for site access and greatly reduces time on site. The photographic data is converted to 3D data using a technique called structure from motion. Other data sets can also be included in the model, such as subterranean obstructions identified with ground-penetrating radar. The model is then mapped to geospace through a handful of traditionally surveyed ground control points. This then enables the production of topographic surfaces in context of high-fidelity aerial photography as a ground truth baseline of existing conditions for design. The 3D asset can also be used perpetually as an asset management tool in the design phase of future site expansion and component upgrades, in addition to being foundational in physical security initiatives. A vulnerability assessment from ex-Special Forces physical security experts, coupled with the 3D asset, can help owners understand their current risk and present mitigation strategies that become invaluable design inputs into the final system design. Using the vulnerability assessment and the existing conditions, the design of an integrated security system with physical barriers and state-of-the-art technology can begin. The working design contains cost and scheduling metadata, so if adjustments are made during the design phase, the impact on cost and schedule is known immediately. Potentially costly situations like design clashes with underground utilities can be avoided when the design process is coupled with a 3D as-built. As the design progresses, constructability reviews between power and utility owners and the project team can happen in a virtual reality environment. This allows an owner to experience the proposed design in context of the existing site months before even breaking ground. An immersive review experience better identifies potential issues, which saves time and money during construction. The virtual design space also creates a way for a physical security expert to validate the effectiveness of the design before it is constructed. All proposed camera views can be checked virtually to ensure that they provide the coverage recommended in the vulnerability assessment. Security experts can also ensure that the physical barrier system mitigates all line-of-sight concerns by exploring the virtually designed site. In cases where civil engineering design is needed to ensure barrier effectiveness, the proposed final grade can be checked in the VR environment as well. One of the outputs of the design effort is a 5D model that couples the 3D spatial components with schedule constraints and cost-related information. The other output is a comprehensive set of construction drawings that contains all of the information gleaned from the intensive design effort, which ensures that proposed project cost and schedule is met.